Good morning. Good morning. So, welcome to this year's Financial Security Conclave. As you know that we had been doing this for almost last 6, 7 years of time, and uh, our annual Information Security Summit that happens in December every year in Delhi is known for the coverage, for the number of sessions, for the possibilities that we create, for the startups we bring to table, for the big enterprises in security that we bring to the table, and the number of speakers, number of sessions, the kind of content that we cover basically. So that's known for that. And we had been started looking and focusing our attention to financial sector security. And there's a reason for that, right? So for example, in last 5, 6 years of time, the kind of history we made with respect to the transformation of our entire digital payment ecosystem to more digital in nature, and where we know that there are some unique stories of digitization all across globe, right? And one definitely we know mostly in the United States, the innovation has brought a lot of those kind of possibilities on digitization of a sector, of a transaction, and more importantly, economy of the country, right? Whereas in case of China, we know that in some years back or till now as well, so government intervention and government investment, government support had got quite a significant digitization, and they did invest quite significant amount to look at the technology transformation and supported many companies also to go to the global market, and their own volume also really helped them to achieve that. And then also the kind of financial planning they made and the kind of entrenchment they have. So this is another story of digitization that we see, right? Then there is a European story we all know of, right? European story is largely the end citizens' privacy or rights-based story, basically, where the citizen or individual becomes central to story, and that's being reflected in the current ruling that they passed against one of the big social media company about some $1.2 billion fine, because the rights become very important part of that. So these are dominant three different stories of digitization, basically, right? And some years back, we also, around 6, 7 years back, we started looking at our story of digitization, basically. And we know that there are something we try to do. So there was a digital payment committee which was set up at the Ministry of Electronics and IT. We had been contributing to that committee, and there was a paper which was laid down, and that paper talked about initially the jam theory, right? So there is an account, Jantan account, and then there is a mobility, and all that coming together could create a possible India's digitization story. So that happened. Some of you must be recalling how we started this story, basically, right? But prior to that, we did one important thing as a country, is this UIDA, right? Aadhaar that all of us has, right? And this Aadhaar, although it's a number, but it's a based on the digital platform. So you can interact, engage with it for various different reasons. One of the reasons definitely we enable at least public sector organization to onboard people using Aadhaar, basically, right? Or even later on we started using Aadhaar as an authentication platform, right? Authentication of transactions, authentication of a user, basically, right? So that we started doing it, basically. And then during that course, basically we found that probably there is a way to look at overall digitization in different way, basically, right? And then the idea of setting up NPCI early 2010s, and that NPCI bringing that interface of UPI, basically, right? What is UPI? It's an interface, right? It's an architectural intervention supported by the government. So this architectural intervention could able to connect to a lot of legacy, because we had a lot of challenges of legacy, basically, of this system. So, but this UPI could connect with a lot of legacy ecosystem, like a bank and a lot of regulated entities. It could be able to connect with that. On the other hand, it could able to assimilate all of those possible innovative small to big companies, right? So we have a lot of payment gateways, we have a lot of small fintech companies, and then we also looked at how somebody like Google and somebody like Meta also is now helping or probably initiate the transaction, basically. So this interface, which had been created in such a way that this interface connects with all the possible dimension, possible players, possible capabilities that you bring to the table, basically, right? And this interface is a more like a protocol, more like a publicly owned interface or infrastructure, basically, and that infrastructure has changed the way things had happened for us in last 4 or 5 years of time. Right now, we are processing more than 9 billion transactions per month, right? So that's the story of India, and the story of architectural intervention, and which changed the paradigm. What was the paradigm some years back? It's like a high value, low volume. When it comes to digitization, some people would use debit card or credit card transaction, and if you look at the penetration of that, very few penetration in terms of credit card transaction, basically, some years back, basically. Most of this transaction would happen high value, low volume. So means you'll do the transaction formally, digitally, but most of the transactions were very high value transaction, but we changed it to low value, high volume game, basically, right? So 20 rupees transaction, 10 rupees transactions nowadays happens on digital platform, basically. And when we have this kind of things, so the one part is definitely volume and scale that we achieved in terms of reaching out the something which the number that we talk about, almost $10 billion per month kind of transaction, where no country come close to what we have achieved in last 5-6 years of time, basically. So this is one key part. But while doing that, we also are able to, because we all know that digitization means what? Digitization means, in a way, unbundling of the every transaction happening, right? So yeah, this unbundling is a concept usually used in a telecom context, basically, where telecom sector some years back has unbundled, and we use same telephone line we had for very different thing. For example, it is used for internet, or it is used for the streaming of a TV, basically, right? So similar things started happening in every transaction line, basically, right? Financial transaction processing has got so unbundled, apart from those core banks, like which has been processing transaction, there's so many third-party interfaces which started participating in processing of transaction, basically. And UPI became that story. So it in a way unbundled the way the transaction would happen, where small companies, FinTech, big companies, big organization, Indian players like a Paytm, like a MobiKwik on one hand, Meta, Google on the other hand, basically now Amazon on the other hand. So it could able to democratize the way the transactions have been processed. And that democratization has also led to quite significant jump in the scale, right? Because we all know that on platform like Meta or platform like Google, there's millions of people. And if same platform can be used for transaction processing, the millions of people can join the digital transaction processing, basically, right? So that started happening, and that's the story that we created. And probably, if you closely follow the way the G20 discussion, which we have been trying to leading, so we are trying to tell the world that there is a possibility of using this approach to make your digital economy successful, or make it early, or make it scalable, basically, the way we achieve, basically. So this is a story that we have created for us as a country, right? And when we say this story, basically, this story is now so spread, and the gains are, for example, the users are gaining out of it quite significantly. So is the technology providers who are gaining out of it quite significantly, because they are becoming part of this entire overall digital economy, and we are trying to then replicate this model to all across the sectors, basically, right? So this is our overall story of India in terms of digitization. But when it comes to now, how the security and privacy discussion evolve around this story, basically. So we know that if there is architecture, we can certainly beef up that architecture, right? Means we had been continuously trying to take an effort that infrastructure, which is a kind of public infrastructure, and that's why we say this as digital public infrastructure, trying to secure that with all possible kind of capabilities that we bring to the table, basically. And this is institutional arrangement that we have in terms of the UIDA, in terms of the NPCI. So we have created those special purpose vehicle to make sure that they behave more like enterprises than a typical government departments, basically, right? And that's why they could able to invest technology, adopt all those possible technological evaluations in terms of security and privacy, fraud management as well. So I had been closely seeing the way these institutions are working. They have been augmenting, and probably they had been, in a way, adopting all those possible solutions that market throws to the table, basically, in terms of security, in terms of privacy, more importantly, in terms of product management as well. Although we know that once there is a significant amount of digitization happen and digital footprint is there, there are a lot of modus operandi that do come into picture when we come in terms of the product management basically. And we probably will be discussing some of this part in some of the sessions that we have in coming 2 days of a discussion. So the financial sector security conclave, so we will like to really look at covering all of those aspects which is shaping the security and privacy and product management discussion around transaction processing basically. But as we had been seen, and some of you must be aware about that, when we arrange or organize something as a Data Security Council of India, usually we spend some time on some of those areas which are very futuristic, but probably we all be reaching that particular paradigm, especially in the today's discussion that I will be talking about, quite early basically, right? There had been discussion about quantum is still 10 years down the line, 5 years down the line basically, so why should we worry about it? And if we have to worry, it's only defense organization, critical organization should be worried, not we as an organization, commercial organization should be worried about this. So we tend to do discussions like this in a breakfast sessions, and there are a lot of such discussion that we try to carry, and now all this discussion that we are now putting it together in some time, we will be probably doing a kind of a 1 day or 2 day event in Delhi to discuss about future of security in coming 5-6 years or down the line basically. So today's discussion that we are starting with, and before I talk about that, these 2 days of discussion that we will be doing as a financial security conclave, we'll be covering various different dimensions, various different kind of issues, interest, evaluations, sectors basically. In BFSI there are different sectors basically. We'll be talking about that in a more dialogue-based kind of interactions that you will have basically. And right from now to tomorrow, today night to tomorrow late night basically, because there is an innovation box that we have planned for tomorrow. Innovation blocks is the concept that we try to get the startups working in cybersecurity, and they pitch in their ideas basically. And where we all join, we vote for those ideas, and some of those ideas will be, and one of those ideas will be known as a kind of a most innovative idea for financial security, because we do it at a national level, but we are largely looking at those innovations which is making sense for the financial security. So that will happening tomorrow evening, and we'll close the event with that. So we have multiple workshops we have planned for today, tomorrow. A lot of parallel track sessions are there, a lot of areas where basically we'll be exploring as a part of this. We will be launching banking privacy guide. We have sectoral privacy project of DSA. I will be launching that guide immediately after this particular session in the Kaveri room. And then we will be also recently work on creating a privacy guide for insurance sectors. We'll be discussing on that part as well. So this particular FinSec is very expanded, evolved, kind of a conference or conclave basically, where you'll see many different nuances shaping the entire financial sector security, privacy, problem discussion, discussed in this particular conclave. And we want to use this as a kind of experiment this year, so that we make much bigger and larger kind of conclave next year basically. So with this in mind, I would like to talk about, because as a DSI, since 2015 we had been following quantum computing, the evolution of quantum computing, and what it is bringing to the table for us. And this particular discussion is very important because now 127 qubit computer is available. Means anybody can access that, because that is being available, which is on cloud, and IBM has introduced that. Anybody in India can now have access to that quantum computer. And the 127 qubit quantum computer, if we know the quantum supremacy, anybody knows what is quantum computing? How many of you know quantum computing? At least 3-4 of you. How many of you know quantum supremacy? Yeah, so what is that? Yeah, so there will be the quantum computing will be reached to an inflection point where no classical computing could really have. There could be some areas, or there could be some things that will be done, where the quantum computing will be reached to that level where no other conventional computing would be able to do the same work basically. So they say there's a 50 plus qubits basically, 49 plus qubits basically. Once quantum computing reach to that level, so kind of work it will do, other conventional computing will not be able to do that work basically. So that level has already been passed last year, last couple of years time basically, right? So we are already quantum supremacy age, where this computing would be not been computed, not been contested, would not be able to with the conventional computing basically, right? And then a lot of those use cases which will be solved by this will not be possible to solve using the conventional computing basically. So that had been already achieved, and at the Data Security Council of India, we had been following this particular area since 2015 or 14 basically, and we have been seeing this happening. And sometimes the prediction which our estimate which has been made in which that this will happen by this time, but probably it's happening almost 1 or 2 years early because now the growth of quantum computing is so exponential basically. So from now to 1 million qubit, at least there is some issue in terms of 1,000 plus qubit. If you solve that, then from this to 1 million will be possible in just only next 6 to 7 years of time, basically. So with this kind of a reality, which we thought that it will hit us 5 years down the line or 10 years down the line, in 2015, when we used to talk about it, people will ridicule us, why you are talking about it, this is not going to happen. But it's already happened now, it's already available now, it's already people are using it, basically. So this is age that we have come to in terms of the quantum computing. It has its own kind of benefits, which we'll talk about that later on, but it also raises a lot of those kind of questions for security that we have designed until now. And some of you know be doing that once it reaches to some inflection point, basically. Once it reaches to some inflection, like for example, 6,000 qubit, and there are already a lot of research is happening that even by using 50 or 100, people have conceptually proved that how it could break the every possible encryption that we have until now, basically. So until now, we had been at a very comfort level because some of the encryption that we invented, basically, some of the encryption that we already deployed, the conventional computing will take years together, lakhs and thousands of years together to break that, basically, right? But now it is possible with what is the capability available to break that as early as possible, and that paradigm is hitting us in coming 2-3 years of time, basically. It's a kind of a something that we have seen in case of Y2K, right? So I don't know how many of you remember or come from that that particular time period where we all, in a way, came to the technology field by serving a lot of things that could happen, and that has thrown a lot of opportunity for Indian people, right? And but at the same time, I was in Department of Telecom that time, so we are such a scare what is going to happen with that, and so that moment is now hitting us basically. In some time from now, in 2 years, 3 years from the now, we'd be hit by this paradigm where most of the encryption which has been built could get compromised because of this capability, basically. So how many of you were aware about this reality of quantum computer? Yeah, Swaminathan. Anybody else? Yes, Ujjwala. So what is your, if I may ask you, basically, right? How do you see, when you are aware about the reality, means what basically it is going to happen with this, basically? So you raise the hand, right? So the mic is there.
So I think the point is that what is going to be sufficient to secure the data or encrypt the data. So as of now, maybe AES 256 and all, we feel it's secure. But as the power grows on, then should we be looking at using quantum itself to create the encryption, so that it becomes, we know how this is going to work, and maybe if we use quantum computing itself to do the encryption, then it might get tougher. Our job will be to make it more tougher for the hackers to decrypt it, So I guess that's what we will need to think through. But as of now, I'm not much aware about quantum computing, but yeah, this is what I understand.
Yeah, so anybody else have any views on this? Yes, Swaminathan. with buying is coming.
Hi, sir. So how we see it today is there is definitely a race for quantum supremacy, and people are actively working on.
Warm. Yeah.
People are actively building on quantum algorithms.
Hmm.
And the number one threat that we should be aware as a nation is that our neighboring countries and some of the other countries have invested heavily. And it will be the first target will always be national critical infrastructure and government and defense agencies, because there is a sufficient amount of investments that has to happen or it is happening to break into such kind of infrastructures. So having said that, so national critical infrastructures, armed forces, these are the kind of institutions where as a nation we should start implementing and start doing the POCs to ensure that we come close to quantum resilience.
Just hold on the thing that you talked about, also the investments happening in this area. In the United States, as a government had invested more than $1 billion in this in last some of the years, basically. EU tried to invest $1.4 billion as a government money to do this research in this area, basically, right? Whereas in China, it's more than almost $10 billion. And some of you must be knowing that they could able to even implement this quantum communication over the air as well, right? Satellite communication as well, right? So around us, that kind of heavy investments are happening, basically. And one of the key thing which is happening, right, you may not break it now. So that scares everybody now. You may not be able to break it in coming 2-3 years of time. Then why don't you harvest every communication that is happening as of now, basically, harvest every data that we see in the encrypted dot, and do us 3-4 the 9, when you have the capability, then you start breaking it, basically. So this is scaring a lot of people nowadays, basically. So until now, we see that, as Swaminathan talked about, largely the discussion was like how to secure the critical sector, and mostly defense. And that you must have heard about some of the news where we talked about how defense organizations are working with some of the companies here to experiment with the quantum security, to experiment with the quantum communication. For that matter, satellite communication, one of the key things which we probably usually don't really factor in the discussion that we have, that the communication system is very basic in nature. Means we say that probably very easily compromisable, basically, right? And it could, the quantum communication or quantum security can really work on that. We definitely talk about that in a shorter while, basically. But a lot of those data which is available now, which can be harvested now, can be broken down the line, basically, right? And probably some people would have already started harvesting that kind of information, basically. And there are already capability investment which are happening all across globe, and also responding to that, we also brought up, like some weeks back, you must have heard that India also signed or probably approved the quantum mission for this country, basically, right? And this quantum mission has almost 4 quantum hub. One is focusing on computing, one is focusing on communication, and a couple of more which are coming as a part of the non-principal scientific advisor, plus Ministry of Electronics and IT, DSC, and other ministries are involved to create India's own quantum mission or quantum capabilities, basically, more indigenous in nature, basically. And there are a lot of those capabilities, right? There are a lot of those component and elements which goes to develop quantum computing, basically. So those are very, for example, there are companies, and we'll talk about those companies in short a while, in India which has developed this capability, right? And there are 2 types of the company that we can talk about. One helping you to become more quantum resilient. For that, you may not require quantum computing as of now, because there are a lot of post-quantum cryptography, ecosystem, standards, algorithms which are getting developed, and some of those algorithms are also getting standardized as well. So there are some people who could help you to achieve that resiliency, basically. But there are some people who would help you to secure, as somebody talked about, that quantum itself can help you to secure or build a new generation security. Some people could help you to build quantum security, the security which is enabled by the quantum capability, basically. So these are 2 key things which we would like to deliberate. One is how do we achieve that resiliency, basically. Other is how do you leverage quantum computing or quantum capability to build a next generation security. So these are primarily me as a security professional which you have joined here. So these are primary areas of focus, basically. So and you can one key part for all of us is to focus our immediate attention to achieve that resiliency basically. So as a Data Security Council of India, and we have this National Center of Excellence for Cybersecurity Technology, and we have started something called a quantum resiliency initiative, where existing infrastructure and existing encryption implementation that is happening all across the sector basically. So can you achieve the resiliency there basically? Can you transform or probably move to the new paradigm where we probably implement or probably revitalize the existing encryption to quantum or restrictive, or more importantly nowadays people call as a concept called as a QPC or PQC basically, post-quantum cryptography basically. Can you go to that paradigm basically? And would that be easy for us? That's what I want to now discuss before we go to quantum security. How many implementation of encryption had been happened, and each and every points where implementation of encryption happened probably needs to change to this kind of a new algorithms which will be post-quantum cryptography. So my question here is, even if you start now, would you be able to do that? And what will be need to achieve that resiliency early basically? Any reflection on this particular point? I'm just trying to estimate the kind of challenges that we all, every system that we have, right from our mobile, that the on-air encryption that happens to the communication that goes to the message encryption that we have, to so many different systems that we basically work with. And the kind of digitization that we talk about, there's so many transactions that we have been doing digitally basically. So there are a lot of those implications where we need to look at that or transition that to the post-quantum cryptography basically. It itself will, yes, Amruthan. Yeah.
Yeah. So, sir, there are two critical points when it comes to quantum as we see it, sir, as a company, 42 Labs. So, we have invented digital identity, and the reason, we want to support from a quantum perspective our nation on critical infrastructure, the financial, the regulators, there is also the importance of key exchange and key generation. So, when it comes to quantum, the most sophisticated attacks will easily, steal the keys, and that's where you lose your data. So if you are able to make those PQC, which is what we have done from our platform, then you will have a very strong digital identity infrastructure to support the transactions and have a very sophisticated indigenous key generation and key exchange mechanism, which is quantum resilient. So that's the area we are working on, sir.
Yeah. So one part is definitely that, because breaking key is a primary target, right? Once you have the capability which can break the keys with whatever big computing power it has basically, then that becomes a very important kind of a target area, and one of the key part of the PQC is certainly help you to have that mechanism in such a way that it could withstand with all these capabilities that you will be seeing in the future basically. This is definitely one of the important kind of PQC algorithm, and there are many such approaches which are coming in, and there are 3-4 of them have been already notified as a standardized algorithm by NIST, and we know that they also started the process of validating the algorithms which will be potential QPC as well, right? And we also know that one of the algorithms got compromised as well. So there is a challenge in terms of that uncertainty as whatever has been discussed as of now could also be becoming something which could be potentially created a problem for us. But there's already some body of work which had happened in terms of what could be potential algorithms or systems basically which could help us save that basically. But currently what we see as a Data Security Council of India, if you try to take this discussion to the security community, so the discussion people see is largely limited to national security, defense or critical sector. So it's not for us. Most of the private sector, public sector organization in different sector like banking or telecom or other sectors had been always talking about this is not for us, it's largely for the defense organization, not for commercial organization, not for the private enterprises basically. But that was a story for probably 3-4 years back basically. But that's not now a paradigm that we see now basically. It is going to hit. It's going to hit a lot of organization which is in both public and private domain basically. So whatever we had been trying to do and experimenting with a defense organization, for example, in one of the defense unit, we have developed and we helped them develop entire stack of a quantum. So when you say quantum stack, what is that basically? So at a layer 3, layer 4, layer 7, you can deploy the quantum stack basically, right? Until now, people were also worried about why should I, even if I decide or discuss or probably think about implementing quantum security or quantum resiliency plan, do you have any capability which can be implemented basically? So one of the key things people have, it's very such a complex, means if I ask anybody here, except a couple of people, Swaminathan, because he's working in that area, so do you really understand the concept of entanglement? Do you really understand the concept of superimposition? So these are the concepts basically people talk about in quantum computing. And this is a very complex mathematical equation. But let's test ourselves. So how much of you understand the basic fundamental quantum mechanism, quantum computing principle? Anybody? What is entanglement? What is superimposition? Anybody? Because that's what it defines the way, because we say 0 and 1 is the conventional computing, here 0 and 1, and there is one situation basically which could be either 0 or 1 basically, right? So, if understanding this basic concept is complex, and it's so mathematically difficult basically, so people are always this one, it's not for us. Do we really want to discuss about entanglement or superimposition? Do you want me to talk about that? Okay. So I'll talk about basic, which is related to the computing itself, basically. So there's a quantum mechanism which talks about there are two particles, basically, which moves in a way that they sync with each other, basically. Right? So entanglement is that there are two particles, be it at a, for example, these two particles could be at a inverse distance long, and they could show the same behavior, basically. So that's called as entanglement. I'm just trying to simplify the definition, not going into too much complications, basically, right? And there is a very philosophical concept here. I'm not sure whether you, and that's why this becomes tricky, because it brings a lot of those kind of ideas which are discussed in the context of philosophy. The quantum mechanism brings that very important concept of philosophy. If a tree had fallen in the jungle, right? Unless somebody sees that, it has not fallen. This is a basic concept of philosophy. The observer's role is very important here. The things would happen only if somebody has seen that, actually. So similarly, if they are entanglement each other, the particular entanglements with each other, basically, and they have been moving, and they are moving the same way, same direction. They may move same direction for quite a large distance. For example, quantum communication, which has been experimented by China, talks about 100 to 1,200 kilometers, basically. So the particle is moving at that kind of a distance, basically. I'll talk about that, how is it really possible to do that or not. If that is moving, basically, and if somebody sees that, then they change the position. So we know that we have seen this flip-flop, basic flip-flops to store the memory or store the message, basically, right? We have seen the transistor which has 0 and 1, and they change the position depending on the instruction that you give, basically. Here what you do, you usually observe. You observe the thing, basically. And because of the observation, the thing gets changed, the situation gets changed, the condition gets changed, basically. And that is being used for build the quantum computer, basically. And this is a so simple phenomena, natural phenomena, means people had been saying 10 years back in India that we lost our best in terms of semiconductor, but nature has again given us an opportunity to work on this. But again, it seems that we are now pledging again a catching up in game in terms of the quantum computer. But this observation, which is a very interesting basic philosophical concept, that unless things wouldn't change, unless something happened. So here you are bringing that particular phenomena in such a way that you can use it to store, you can use it to communicate. For that matter, if you're building the communication system, quantum communication system, And we always have this problem of a man-in-mineral attack, basically, MITM that we talk about, man-in-mineral attack, basically, right? So it is very easy for you, basically, to address that challenges, because once somebody sees it, it changes the behavior, basically. So man-in-mineral becomes very difficult to possible in a quantum communication. That's why the quantum communication phenomena can be used for a secure communication, basically, right? Because the basic science here is coming to the aid, and there are a number of research institutions in India and startups have been now leveraging that, who has developed that natural phenomena. There is a single photon detector for that matter. There's somebody who has used natural phenomena to provide you that entropy. This entropy is called as an entropy which can be used to randomize it, right? So until now, we always use the pseudo-random numbers basically to build the quantum, build the encryption. But now there is a quantum random number generation. So natural phenomena have been used to create that randomness basically, right? So some of these ideas which is being used, and I don't want to get too much dwell into, because after this I would like you to go to the basics of the quantum computer, basics of the quantum phenomena, and how that has been leveraged basically. But the danger here that we see for various different things basically, right? Most of the defense communication on satellite, right? And satellite communication has its own challenges basically. Imagine somebody is trying to harvest that communication basically for the future kind of thing. So definitely it has a lot of sense in critical and national defense ecosystem, and that's why we, as I was talking about, so one of the Army unit, we had helped develop entire quantum security stack at a layer 3, layer 4, and layer 7. And this has involved also 3-4 things basically. One is definitely QRNG. So when we talk about quantum stack, we talk about 3-4 things basically. One is the quantum random generation. So that's the QRNG that we talk about. The another thing is a PQC, like post-quantum cryptography. And third important thing, which nowadays is evolving, is end mobile or device level, there is a quantum walk. It's how do you store keys in a more secure way, basically. And then you can implement this at layer 3, layer 4, layer 7 as well, at application level as well, at a layer 4 and layer 3 level as well. And then you create an entire ecosystem for that. So what it tells us is that when we say that we have implemented it, it tells us that there are technologies which has come to deployment level, basically. So both PQC, both QRNG, both quantum walk is come to the level of actual deployment, basically. Come to level of actual rack level deployments. Means there are racks, like servers that you have, is available you for deploy, basically. So single photon detector for that matter you can buy that device and put it into your data center, basically. And start getting that entropy, right? You know entropy basically. Start getting that random number from that and build algorithm on top of it basically, right? So the rack level deployment, and that's the very interesting important thing which started happening, is there are almost 8-9 companies in India which has quantum security capabilities basically. I think some of them would be here in the particular pavilion that we have, and probably they're almost like one set of company I talk about is which is building the PQC. For that matter, 42 Labs has been working to develop the encryption which could withstand with quantum. So that's set up companies. Other set of companies which are using the quantum phenomena to build a solution on top of it. For that matter, there is a RST which is based out of Pune, which is using quantum entropy and helping you to develop the messaging platform which is more secure. Not only secure, but you can use multiple use cases on top of it basically, right? Or it can be used to transfer data, big data from one location to other location. There are a lot of critical sector organizations do transfer data which is very sensitive in nature, but transfer in a very conventional manner basically. And they are worried about the backup, they are worried about those data that get transferred basically. So there are companies like RST, which is based out of Pune, 4 engineer, freshers. Some years back, they started thinking about doing, and they have been working with Pune University. There is a incubation center there, Bhau Institute, basically. They are working from that. There's a Skytel Alpha, basically, which is a Delhi-based company, with whom that we build this kind of a quantum security stack. So they have rack-level implementation of all of this technology just talked about, basically. And they have been now, as they had implemented in one defense unit, they have been now working with the Navy and other defense unit in terms of implementing this basically. There's a CUNU lab. Some of you must be knowing that organization, which is like a globally known now. It's a very leading organization out of India. Some researchers in IIT Chennai with some people from the industry came together and they set up this particular company, and they have a very commercial level. Means the products that you see is a very the look-wise they're very conventional in nature, but work-wise they use this natural quantum phenomena to deploy many of those kind of things. So they have very commercial level enterprise grade technology available, which can be immediately adopted. Then there is a Q lab, which is again IIT Hyderabad initiated. Professor Nixon Patel, who had been inventor of this particular company, and there are almost 40 researchers, core researchers working to solve many problems or components and kind of elements which is in a way building the quantum computing, but also leveraging those capability for the building better security basically. Then there is a QPI technology, which is again the Bangalore-based company, which has a lot of those basic capabilities of a quantum computing and security, but they are building, one of the important things, they are building the quantum enable or quantum level data center as well. So this is one of the important things. I will talk about others, but I want to get your attention to things that are going to happen in coming 5-6 years of time, basically. So we all know that still we had been using conventional computer, and conventional computer itself will be reaching to its own limitation in some time, basically. So we all will probably have 1.4 nanometer processor in your mobile by 26, 27. We will see that the kind of a hardware that we see evolving and semiconductor ecosystem is evolving quite a significant speed. Your own mobile will have probably 500 to 600 MB kind of a camera. You would probably have 10 Gbps kind of a second, 6G speed in coming future, in coming 3-4 years of time. So such kind of a thing which is going to happen. So the conventional bit computing will be still there. But as we know that IBM recently bought 127, by end of year they have been talking about 1,000 qubit, by next year they're talking about 5 to 6,000 kind of a qubit, and after 6,500 qubit, things will start becoming messy for us. Because that's the inflection where it will start breaking a lot of encryption basically. IBM is saying that by next year they will be trying to bring those kind of capabilities, and by end of some this quarter, people are saying 1 million qubit quantum computer is possible as well. So the qubit is also, so bit, qubit, right? And this third thing which is also happening from the computing perspective is the neuron computing. Is the computing which is now brain-inspired, biology-inspired computing basically. So, and then that's called as a neuron computing. Neuromorphic computing is people talk about basically. So bit, qubit, and neuron. So these are three things coming together. So there is a QPI tech which is building data center solutions which can help you to work with all this together. Bit, qubit, and neuron basically. So depending on the workload that you have, depending on the kind of application you have, you can have same data center doing all of these things basically. So just data workload which is require you quantum computing, it will send to that, something for the conventional, something for the neuron computing. So they are building that kind of solutions out of Bangalore basically. So there is a company which is incubated company in DSI own incubation center is building quantum chip basically. So what I'm trying to tell here is, and then there is IBM, there are Tech Mahindra, and there are many other organizations basically which are building those kind of capabilities, and these capabilities are now coming to implementation level. So you need to have to go to a lot of complications and complexity in terms of understanding it, but you have to prepare to see which one of that can be leveraged basically. So we know that PQC is another important part, and that will be one of the important things that people will be looking at when we have been trying to make a plan where all these organizations which are developing PQC algorithm, then the reliability of that algorithm is very important. So we are trying to, with some of the researchers, we are trying to set up a small kind of initiative to evaluate those kind of algorithm and help that evaluation for you so that you can get them and implement in your organization, basically. So kind of evaluation platform, a testing platform for the PQC algorithm, we are trying to make that. So all this ecosystem in a place for you to leverage from. And that needs to be taken at least initially to POC level. And this quantum resiliency plan that we have, a program that we have been looking at, we are looking in such a way that we need companies to come forward and try to see at least do some kind of piloting with this kind of capability available. And there are enough startups which are working in this area, and there are some global Indian companies working in this area. So that's the effort that we are putting together from Data Security Council of India perspective on National COE that we have set up for technology development entrepreneurship. And we need people's participation, the organization's participation to experiment with some of these things that we will be doing as a part of this. And then at the same time, we all need to learn the skill because maybe it will be something like Y2K movement for us for next 2-3 years of time, providing a lot of opportunity for all of us as a security or privacy professional or development professional. So we should make ourselves ready for that as well. So this paradigm, this ecosystem, the attempt here is to let you know about their challenges and opportunity as well. There is enough opportunity in terms of quantum security. You can beef up entire quantum security using quantum capabilities, basically. And then there are a lot of research happening. Startups are there, basically. But we need to now inculcate. In our day-to-day discussion, we don't really talk about this a lot. And we want to see that happening from now, from the ACI. And anybody interested, please feel to connect us, and we will try to then get you engaged into some of the work that we'll be doing. From some time from now, in Mumbai, we have done something in Delhi, but in Mumbai, we'll be doing some kind of quantum resiliency specific meetings, basically bringing those startup researchers to the table and getting exposed them to you. And also, we'll also come up with a kind of how this has been implemented in defense and other organizations as well. So this is what something we want to really explore, and this is what something I wanted to talk to about how should we all prepare for both challenges and opportunities that is being thrown because of quantum computing. So we can close this, but before I close, if there are 1 or 2 questions or observations on this, we'll take that and we'll close this basically. Anybody? Is it too complex to understand or? Should we then conclude this? Yeah, here we. Yeah.
So will the superconductivity enable some of the computing?
Yeah, so superconductivity is one way to achieve quantum computing. There are different ways, basically, trap ion, photonic, superconductivity. So there is interest we can discuss about that, what is taking you to the quantum computer, basically.
Because you spoke about layer 3, layer 4, and layer 7. So how about layer 1 and layer 2? Will superconductivity help in that?
Yeah, so building computer, you require that, right? But when you are using as a consumer of a quantum capability, you may not require to think about all that possible, right? Because there is a building and there is a building of computer and there is once it is built, is being available to you, basically. But when you are talking about building the supercomputing, there are a lot of things, a lot of areas that can be discussed at a layer 1 to layer 7, basically. But as a user, you would need this capability as we understand now, and understanding is still limited because there are only 3-4 examples like this. As we understand now, there is you need layer 3, layer 4, layer 7 level of capability for quantum. Yeah.
Yeah. So I have a question specific to the finances side of this, because we keep speaking about a time when, the regular kind of cryptography is no longer going to be existent. Is there going to be an inflection point in terms of how much money is required to build a sort of quantum computer?
Yeah, there are some countries which are making plan for that. They are trying to create an incentivization plan to help organization to come out of this, basically. But PQC implementation may not cost you quite significant money, but the only challenge is keep your encryption is developed in such a way that algorithms is not independent of the platform or system. Then it's difficult for you because you have to change entire system. But at least you can do that. If your system is independent of the algorithm, it's easy for you to do that, basically. Yeah, reveal take a last question from Ravi and we'll close.
So, thank you, sir, for articulating such a complex thing in such a easy way to understand. So one of the things my request is it possible for you to organize sessions for business people, wherein we can start thinking about how to leverage this in different places?
Yeah, so the plan is the acceleration program we had now kicked up in Delhi a couple of months back. We'll be doing multiple such kind of sessions for very different kind of people. Those who are interested in cryptography, we want to help them understand that more bit interesting. If somebody is helping, there is a quantum mission of Government of India. I'm leading or chairing one task force basically, which is talking about ecosystem, quantum computing ecosystem basically. And one of the key things is how do we get people engaged on this dialogue and make them understand this better and get them involved in this kind of work basically. So that definitely at the government and data security consultant level, we have been working to create more awareness about this and as early as possible because that reality is just hitting us now.
And then there are two components there, sir, like you rightly mentioned. One is from the defense and the security perspective.
Yeah.
Now, there are a lot of things happening inside. When you look at a bank, there are a lot of things happening inside a bank which is taken for granted.
Yeah.
So this is relevant to them. To give a perspective, I don't want to name the country or the banks and so on.
Yeah, there are a lot of commercial use cases
Yes.
which will be not possible until now will be possible with this.
Right.
Means I'm not talking about, not discuss about what it will lead to in terms of how commercially you can leverage it for various different things basically, right? But within the bank, I think what we are suggesting is can you create a mapping of the different processes and see which will be hit by this more,
Right.
both from perspective of challenges and issues, and other is the opportunity in each of that basically. So we want to do that exercise for sectors basically.
I see it, impacting everywhere
Yeah.
inside a bank.
Yeah, it's a natural phenomena, right? And being available to you in a very easy, commoditized way, basically. It will hit coming 2 3 years, you will see a lot of things are happening out of it,
So
basically.
to give a small perspective, when COVID was there,
Yeah,
including simple thing like, the security between a core banking system and a database is like, nobody touches it,
Yeah.
it's not even human. We saw in some countries, people hacking that bit out to such an extent, people were not even aware that, what is happening.
yeah.
Now that means every interaction that is happening inside a bank, if this information, harvesting model is
So
available-
harvesting is a big risk in this as of now, and that's what we should all be for that, and that's why we should be preparing and going for that paradigm as early as possible. But I'm sorry, I know this interaction is quite intense interaction. We would be doing many such interaction in different cities of the country and create more opportunity to discuss about this. But we need to move for the next thing. So quickly we are going for that, and I'm thankful all to be part of this interaction and be here. But we close it with this and go for the next all 2-day long programs that we have basically. You want to announce something?
Thank you so much, Vinayak. I think he can talk for a whole day on this topic. He's very passionate about this. So may I request you to join us for a banking security and privacy guideline launch in Kaveri room. Vinayak, I think you should proceed as well. Thank you so much for joining this session. Thank you.